Everything you see around you, and the era of the universe in which it was formed, has been largely confirmed through thousands of studies, experiments, observations, and publications. It's worth noting that the Big Bang is taken as a reference point for these works. Although the Big Bang itself remains a controversial topic, there is a broad consensus in the scientific community about the formation times of objects that emerged afterward. If you look at this matter solely from this perspective, everything seems to be in order according to the Big Bang and the standard cosmological model. However, this situation held true only until 2013, when the Max Planck satellite measured the cosmic microwave background radiation in unprecedented detail. It revealed that we have no idea about 27% of the matter in the universe. As you know, phenomena we can only infer indirectly, but cannot directly visualize with current technology, are categorized under the term dark. Dark matter and dark energy are the two most famous concepts in this category. Our cosmological model, which claims to explain everything, offered only faint propositions about when and how dark matter formed. These propositions were so weak that they were almost universally ignored. The silently accepted assumption was this: everything formed with the Big Bang, and dark matter somehow emerged during those initial moments. According to the 2013 measurements, the total size of the matter we can observe constitutes only 5% of the entire universe. In this case, someone might have raised an important critique, saying the Big Bang Theory, which bases nearly all of its explanations on visible matter, actually explains only 5% of the universe. Such a critique could have been a crucial reminder of the need to redefine the current boundaries of cosmology. However, it's important to remember that scientific theories are not ultimate truths, but the best explanations based on existing data. Even so, the scientific silence surrounding the formation of dark matter and dark energy has always been a question mark, at least for science enthusiasts like us. This situation persisted until 2023. Two studies published in 2023 and 2024 could fundamentally change our understanding of the universe's beginning. In fact, given how little we know about dark matter, it's more accurate to say these studies might initiate a new enlightenment process rather than overturning our current knowledge. Researchers from the United States and Sweden propose a new theory about the beginning of the universe, which they call the Dark Big Bang. This theory suggests the possibility of a second Big Bang of a kind we've never heard of before. Moreover, it questions the fundamental argument that the Big Bang is the source of everything. However, this new theory is not yet proven. The Big Bang Theory, as we have known it until today, posits that the universe began expanding approximately 13.8 billion years ago from a very dense and hot point, explaining the origin of everything visible and invisible. But when this theory was proposed in 1927, the concept of dark matter had not yet been discovered. The term dark matter was introduced to the scientific community by physicist Fritz Zwicky in 1933. Observing the Coma galaxy cluster, Zwicky realized that the movements of galaxies could not be explained solely by the gravity of visible matter. To account for this missing mass, he used the German term Dunkelmaterie for the first time. This discovery indicated that the universe contains much more than meets the eye and suggested that the Big Bang Theory would need to expand its explanations. It would take until 1978 for the concept of dark matter to gain serious attention from the scientific community, thanks to Vera Rubin's publication. Rubin was the first person to notice that the Andromeda galaxy rotated much faster than its mass would suggest. By 1978, the concept of dark matter was known worldwide. The existence of dark matter was only confirmed 51 years after the publication of the Big Bang Theory. After this point, efforts began to include the formation of dark matter in cosmological models. However, a widely accepted model on this topic could not be established. It appears that dark matter was assumed to have formed during the universe's early moments, and theories directly explaining this formation were not seriously pursued. In reality, it wouldn't be an exaggeration to say that only a few scientists paid attention to something we know exists but don't know what it is and cannot directly observe. Think of it this way. Until the 2000s, if you search for detailed articles on this topic on Google, one of the most common sources you'd encounter would be physicist Lisa Randall's book, Dark Matter and the Dinosaurs. In this book, Randall proposes a new theory about the asteroid that wiped out the dinosaurs. According to this theory, the asteroid might have been directed toward Earth by the gravitational pull of dark matter disks. These dark matter disks are structures within our galaxy that are not yet fully understood. Randall explains this idea in an engaging and clear way in her book, which we highly recommend to anyone interested in both the extinction of dinosaurs and dark matter. By 2023, we see significant research on the formation of dark matter being published. An American physicist study claims that dark matter and dark radiation could have formed through a separate process after the Big Bang. In popular scientific terms, this interpretation suggests that there were actually two Big Bangs, one of which was exclusive to dark matter. Scientists propose that the traditional hot Big Bang filled the universe with observable matter and radiation, but dark matter may have formed independently of this process. The paper suggests that dark matter and dark radiation formed during the very early stages of the universe, when dark vacuum energy underwent a phase transition into a hot dark plasma. Expanding on this idea, quantum field theory posits that there is an inherent energy within the fabric of space caused by natural quantum fluctuations. It's thought that this energy underwent a phase transition or transformation to create dark matter. Another study in 2024 detailed this phase transition further, suggesting that the dark sector might have experienced a dark Big Bang through quantum tunneling, surpassing an energy barrier. This phase transition was modeled in the same paper, and the results align with the predicted matter densities after the Big Bang. However, as always, the study concluded with a call for further research. In summary, these two papers propose that dark vacuum energy may have transformed into dark matter through a dark Big Bang. This presents a new and intriguing perspective on the formation of dark matter. Dark Big Bang theories have faced significant criticism due to a lack of observational data. For example, the absence of any gravitational wave evidence linked to a dark Big Bang has increased skepticism among critical scientists. However, the major issue is that if a phase transition like the dark Big Bang had occurred, it would make the explanation for the early universe's helium abundance, one of the cornerstones of our cosmological model, untenable. If you can't explain helium abundance, then you'd need to seriously question or even discard the current cosmological model. For this reason, dark Big Bang theories are heavily criticized for being incompatible with the existing cosmological model. However, a paper published in 2024 proposed a test method that could address these criticisms. It stated that very powerful gravitational detectors could measure the predicted results of this paper. Ultimately, when the Einstein telescope and LISA detectors currently under construction in the EU and the US are operational, we might finally get answers to our questions about dark matter. See you in our next video.